Hi everyone, welcome to the webinar series here. Um, I am Anand Patil. I'm the director at Bridge Software Institute. And firstly, I wanted to make sure everyone can hear me. All right, please raise the hands if you can hear me. I see one, two, three. Okay. Okay, so everyone can hear me. So today is the second of our webinar series, creating bridge model in FB-MultiPier. And Wilmer Carrion will be presenting here today. We did do our first webinar back in August, and we do have the video recording of that on YouTube as well. And if you need more information on the materials and other stuff, please reach out to us. We can provide them to you. Um, and the next webinar is scheduled for January 21st, 2026, and it would be advantages of using bridge models. And you please do register for it if you haven't done already. The registration is on our website, bsi.ce.ufl.edu/webinars. But if you cannot find it, let us know. We'll send you a link as well. So before we start here, I want to take the time out. I want to take some time to thank you for taking out of your time for this webinar. And I want to make sure we use your time wisely here and provide you with best possible, you know, um, best possible way of using our program. So our goal for today is to help you understand how every multi-peer program works, specifically in the bridge models, and provide you with training on effective ways of using the program by demonstrating step by step the process of creating a bridge model in FB-MultiPier. As far as the agenda goes, we have distributed in the three sections here. The first few minutes are for welcome and introduction here, followed by the actual webinar content. And we have kept 10 minutes at the end of the webinar for any Q&A or discussion. Um, Please be aware for all that online attendees should be muted during the presentation. And if you have any questions during the presentations, please use the Zoom Q&A section and put your questions there. Clint and myself, we will go through it during the presentation and we'll answer it as much as we can. If you want to ask a question directly to us, please wait till the end of the webinar for the Q&A section here. And if you have any questions, raise your hand then, and we will unmute yourself and you can ask the question. So if by any chance we were not able to answer any of your questions today, we will reach back to you with an email or a phone call, and we want to make sure that we answer all of your questions. Lastly, I want to mention that this webinar is being recorded, and we will try to put this on the YouTube as well. So without further ado, let's start the webinar for today. Wilmer, please take over.
All right, thank you, Anand. Hi, I'm Wilmer, and I will be leading this part of the webinar, which has to do with the process of creating a bridge model, and also gives some context for the various features within FB-MultiPier that are specific to bridge models. And I'll be starting with some slides here to help explain some key concepts, and then I'll switch over to a live demo of FB-MultiPier itself. So first, I'd like to talk about some aspects of bridge models that differentiate them from our other model types that we have in our program. And one of the most important things to note about bridge models is the fact that we use a linear elastic spine model to represent the superstructure, slab, and girders. And there's two options for supplying input to describe the geometry and material properties of the superstructure. And the first is through input of gross properties, where you directly specify quantities such as areas, moments of inertia, and moduli that represent the entire cross-section of a given span portion. And you also have the option of inputting more detailed descriptions of the superstructure cross-section at any portion along the length of a given span. So in this case, the geometric and material properties of the slab are input distinctly from the girders. And so the girders will also have their own set of geometric and material properties. And then during analysis, FB-MultiPier takes the detailed superstructure description and then calculates an equivalent spine model. So again, just want to reiterate, in both cases, a spine model is ultimately what is used during the analysis. And also, by default, FB-MultiPier uses a kind of straight connector between piers, but you can customize the nodal coordinates along the spans, which gives you more control if you wanted to model something like curved spans, for example. So at the superstructure-substructure interface on top of each pier, you'll find several automatically generated elements, which we refer to as intermediate elements. And there's a vertical link, a transfer beam, and for interior piers, there's a continuity link between spans. And what these elements do is they help to ensure that loads are properly transferred between the simplified spine model that we use and the underlying highly nonlinear structure and soil. And so let's go through these intermediate elements in a bit more detail using this schematic. And we'll start at the top at the superstructure beam, which is the spine, and then work downward. So at the end of the superstructure beam is a stiff vertical member, and that's what we refer to as the vertical link. And this vertical link enables connectivity between the superstructure center of gravity and an immediately underlying transfer beam. And in turn, the transfer beam is typically very stiff and allows for loads to distribute to the bearings on the pier cap. And when you're letting the program generate these intermediate elements, you get a very stiff transfer beam by default. And the reason why is that we want the transfer beam to transfer loads in proportion to the motions at the superstructure level and get a good distribution of bearing reactions. Again, given that we're working with the simplified spine model. So in short, the vertical link marks the center of gravity of the spine model and brings the loads down onto the transfer beam, and the stiff transfer beam spreads the loads onto the bearings. Now, if you have two rows of bearings and the span is continuous on top of a pier, then you can model the third intermediate element, which is the continuity link, which basically adds an element that connects two adjacent spans together. And that can be very useful in some scenarios, like, for example, if you have a continuous deck slab, you can assign properties to that continuity link to match the properties of just that continuous deck slab cross-section. Now, I mentioned that the relatively stiff properties of these intermediate elements are all automatically generated, but if you'd like to impose a different set of conditions or change the behavior of the load transfer at that interface, these properties can all be customized. So there's three common ways to generate a bridge model in FB-MultiPier. And the first is to start with the default bridge model, which is a 3-pier, 2-span model as shown on the lower left here. And the second is to start with a single pier or bent model. And as long as you have bearings defined on your model, you can directly convert the model type within your FB-MultiPier session to a bridge model, and then customize your model further from there. And third, if you have some pre-existing custom models that you like to use, such as the one shown on the right, then you can take any of these individual models and combine them together into one unified model that is a bridge model. And for this series of slides, we're going to start with a default model first, and then in the live demo part of this, we'll actually start with the customized model, which we developed in the previous webinar. Okay, so now we'll have a brief FB-MultiPier user interface modeling overview section, just to kind of highlight different parts of the interface that will be important to us as we build up our bridge models. Now, you don't need to follow along in the actual program, but if you'd like to, I will be pointing out different areas and buttons on the interface that you would need to click or navigate through to access whichever dialogues I'll be talking about. So let's start from scratch here and open up a default bridge model. And if we click on the New File button to launch the Select New Model Type dialog, you'll see that there's two bridge model types available when we're starting from scratch. The first is the bridge model type, which is self-explanatory and serves as the default, normal bridge model that we have. And the second one is a one-pier, two-span model, which is a special case of a bridge model, and we'll get into that one a little bit later. Did I skip a slide there? No, we're good. Okay, once you click on the bridge substructure type on the Select New Model Type dialog, the model page will show that you have the bridge model selected, while the other quadrants will show some bridge graphics windows. And now most of these pages are pretty much the same as when we were using the single pier models in our previous webinar, like the analysis settings or other pages under the substructure section. So I won't be really talking about them. You'll see that the two quadrants on the bottom, which were previously the soil edit view window and the 3D view windows for single pier models, have been replaced by the 3D bridge view window. And similarly, the pile plan view window has been replaced by the bridge plan view. And now we're seeing these full model overview windows because of the page that we currently have selected. When we click on pages under the global data section or the superstructure section, we're presented with views that represent the entire model, since the data that can be viewed or modified on these pages have to do with the model as a whole and not any individual substructure. So zooming in on the 3D bridge view for a minute here, this is very similar to the 3D view when using a single pier model. You can do all kinds of things on here to inspect your model, like panning, rotating, zooming, and toggling on the finite element mode to view the underlying finite element model using the thin elements. And I just want to emphasize here that there's a lot of functionality available on the context menu, which you can get to by right-clicking on the window itself. So it's definitely helpful to just take a minute here and look through the options just to make sure you're aware of everything that you can do on this window. Now here's the bridge model in the bridge plan view at the top right of the interface. And it's similar to the single pier pile plan view, but instead of viewing piles within a pier, we're now viewing piers within a bridge. Something you can do on this window is use the span selection context menu option to select any span and gain access to the bridge span properties dialog for that span, which lets you view which lets you view or modify the geometric or material properties of the selected span. But we'll cover that dialog in a bit more detail later on. Now, if we click on one of the pages under the substructure section, all of the 2D and 3D graphics windows will change to match the single pier layout for the currently selected pier. And to switch between substructures in your model, you can use the substructure drop-down box at the top of the interface at any time. So for example, if you select substructure 3 using that drop-down, all of the pier-specific pages under the substructure section will switch to behave as inputs and show data for pier number 3, and all graphics windows will show pier 3 as well. Now, the most important bridge-related model input page is the bridge page itself. This is where you'll be able to do things like positioning the currently selected pier in the global coordinate system, adding, removing, or replacing certain substructures, or importing a substructure from another model that you've perhaps already created beforehand. And this is also how you access the custom bearing condition dialog to allow you to model complex bearing conditions on each of your piers. So let's actually take a peek at this dialog by clicking on the Edit Supports button. And the main table on this dialog will show all of the bearings in the current substructure, which are the rows, and the behavior for all of their respective degrees of freedom on the columns. And each degree of freedom for each bearing can be either constrained, released, or if you want more freedom, you can supply custom bearing curves using the button on the lower left. You can also use the pre-configured fixity options to save some time, like the pin option to make all bearings act as pins. Now, back on the bridge page, let's take a look at the bridge span properties dialog by clicking on the Edit Span button. And clicking that button is the second way of getting to this bridge span properties dialog. The first way was using the bridge plan view, which I had mentioned earlier. And this dialog has quite a few sub-dialogues that control various properties related to the spine model that we've talked about before. Now, I won't go into too much detail, but basically, this is where you would define your span nodal coordinates. This is where you would input span temperature loads, span section properties, and also section properties for the intermediate elements that we talked about before. And a lot of these sub-dialogues have schematics, like the one shown on the screen here, to help them understand, or excuse me, to help you understand the finite element concepts at play here and how that translates to inputs that you would provide. And so that's it for the edit side of the program. Now let's run an analysis and look at some results for bridge models. For the results that are reported on a peer-specific basis, viewing results data for a bridge model is very similar to a single peer model. So here we have pulled up the column and cap results view, and the layout is exactly the same as the single peer model layout. The only difference is that now we can use the substructure selection drop-down box to choose which substructure we would like to view results for. Similarly, when we first navigate to the 3D results view, it'll look exactly like it did for a single peer model, and we can iterate through the substructure selection box to see results for each of our peers individually. To be able to actually see some spine model related results, let's activate the bridge view context menu option, which will allow us to see the entire finite element model at once. So here's the 3D results view window with the bridge view activated. And this will give us access to a few additional context menu options as well. One of which is the element forces option. So clicking on this opens the element forces dialog, which allows you to click on any element along any of the spans and see internal forces and displacements in the tabular kind of form here. Another option is the bridge span force plot. This will open up the bridge span force plot dialog, which plots the shear and moment diagrams of the span elements directly on the spans, and also shows the max and min shears and moments. And the last thing I'd like to talk about this session is the specialized bridge model, which I mentioned at the beginning, which was the 1-peer-2 span model, or the OPS model. This model is useful for when, for example, if you have a large bridge model with many substructures that perhaps takes a very long time to analyze, but maybe for the moment you're only really interested in the behavior of a particular substructure, but you still want to capture the stiffness provided by the rest of your bridge. So when you have an existing bridge model and you convert it into an OPS model through the interface, FB-MultiPier conducts a special analysis where it takes whichever pier you've selected and its adjacent spans and replaces everything else with springs at the ends of these spans. And the stiffnesses of these end springs are calculated based on the rest of the substructures in your model. So when you do go to run the analysis, there's a lot less nodes and elements that the program needs to consider, which greatly reduces the computational time. In terms of available features in the interface compared to the regular bridge model, the OPS model is similar, but there's one additional dialog specific to this model type that I'd like to show. So on the bridge page again, we will now have access to the OPS data button, which opens up the OPS data dialog. And this dialog allows us to customize all the data relevant to the OPS model, including the global coordinates of the span end springs and the actual stiffness matrix used by these springs. All right, so that's it for the kind of theory and interface overview regarding bridge models. Now let's move on to the next part, which will be more of a live demo within FB-MultiPier itself. And it'll actually pick up right where our previous webinar left off, in which we created a single peer model from scratch. Now, if you didn't get a chance to attend our previous webinar, no worries. I'll give a very brief summary. And the model we will be starting with has actually been provided to you as well. So in our previous webinar, we built up an FB-MultiPier model to represent one of the piers on the Melbourne Causeway in Melbourne, Florida. And we started off with a default pier model. We modified the pile cap grid to split up the two portions of the pile cap here. And we also learned how to add in extra members to connect the two columns near the bottom. And the model we ended up with in FB-MultiPier is on the right. Our first goal for this session is to take the pier model we previously built up and convert it into a bridge model that somewhat represents the full bridge. And I say somewhat because we will be making many simplifications since we have a limited time frame. So for example, the real bridge has over 20 spans, but for this session, we'll just be modeling 4 spans and 5 substructures. And we will have a pier in the center that's a bit taller to represent the middle portion of the bridge, as well as 2 end vents on either end of the bridge, which should allow us to see and use many of the different modeling features available for bridge models. Our second goal, if we have time near the end, is to take this one step further and convert our bridge model into an ops model with Pier 2, which was the original pier that we built up, as our focus. Okay, so let's go ahead and open up FB-MultiPier if you'd like to follow along. So first, before I open up a model, I'd actually like to talk about the models you've been provided. So the one we'll be starting off with here is the Melbourne Causeway EB Pier Final model. And again, that's the same model that we ended up with in the previous webinar. And these other 2 models are what we will end up with after we make all the changes to the pier in this webinar. So just in case we get, kind of lost or we make a mistake along the way, you can directly load up these models and play around with them if you like. So let's go ahead and open up the pier final model, and I'll just drag that straight onto the FB-MultiPier interface. All right, and now we have it opened up. So the first thing we want to do is actually convert this into a bridge model type. So I'll go ahead and click on the bridge model radio button here. And now what will happen here is FB-MultiPier will take a copy of your substructure. So that'll include soil, loading, all kinds of things like that, and move it a certain distance away from your existing pier and actually generate a span between them. So we'll press OK on here, and that'll directly open up the bridge span properties dialog for you to modify this automatically generated span. So let's go ahead and dive in here. The first thing we want to click on is the section properties and temperatures button. And we'll check the compute transform section properties. And then we'll click on section properties. And now this is kind of the master dialog for anything related to providing a detailed description of your span cross-section. So kind of starting at the top left here, I'll give a very brief overview of all the input options you have here. The first is this uniform shape checkbox, which if you uncheck it, allows you to have or to distinctly define geometric properties for girders along a cross-section. But we'll keep that checked for now since we want to keep this simple. We'll have all the girders be the exact same cross-section. And further down here, we have the girder type drop down, and we have a few different kind of girder materials available, but we'll keep it as steel for now. And then we have this girder spacing typical section button, which opens a similarly named dialog. And here is where you can actually define the spacings between your girders. Now, by default, it'll use the spacings of the bearings that you already have defined on your model. So that's what we're seeing here. And if for some reason you don't have to change these, but I'll just change this for demonstration purposes. For some reason you have some numbers on here and you want to reset it back to the bearing spacings, we have this button, use bearing spacings, that you can use to reset everything back to match those bearing spacings. And then you can also plot these spacings to make sure that things are looking good. And we have some girders here kind of floating in space, but we'll fix that in a minute here. So we'll press cancel on there and cancel on here since we haven't changed anything. And then further down here, we have inputs for material properties of the girders and the slabs. And we have a table as well for the kind of every section of girder that you may have. But the only thing we'll end up changing on this dialog is the slab width. So let's go ahead and change this from 390 to 640. So 640 inches for the width. And anytime I make any changes on this dialog, especially relating to geometry, I like to click on this plot button here and just make sure that there's no weird typos I made in my geometry inputs. Just visually inspect this to make sure it makes sense. So all is looking good. There's no more girders in space. So we can close out of here and press OK. And we'll press OK one more time. Now, as soon as we press yes on this message box, this is when the program will take the detailed material and geometric properties we've just specified and compute equivalent gross properties for the elements that will make up the spine model for this bridge. So let's go ahead and click yes. And now all of those elements have been updated. And to actually view those properties, we can click on the table button here under the cross-section section of this dialog. And you can see the material and geometric properties for all of our span elements here. So that's really good for, just quick reference if you need. So we'll press cancel on here and we'll press OK on the bridge span properties dialog. And now we're at a point where we can save the model, but before we save, if we do save right now, it'll actually overwrite the previous pier model that we had from the first webinar. So I'll just go ahead and do a file, save as. And I'll go ahead and name this Melbourne Causeway EB Bridge 2. Okay. All right, now we're good to go. And so now we should have two identical piers and a very slightly customized span. And now we want to customize our second substructure to represent a pier located near the middle of the bridge, which is going to be a bit taller. So let's make those changes to pier 2 and take a look at some things we might need to watch out for. So let's navigate to the pier page. And we'll use the substructure combo box here at the top for the first time to select substructure 2. And we're going to be using this box a lot, so just keep in mind where this box is. And let's change the pier height to 32. Press enter. And now we do have the height where we want, but I want to point out that on the columns, because the number of nodes did not change, that means the spacings between the nodes has changed, which also means that the extra member which we had connecting the columns likely has moved as well, which we may not want. So to investigate that, I'm going to use one of our new features in the program, which is the measurement tool. And I'll go ahead and right-click within this 3D view window and click on the measurement tool option. And that'll open up the measurement tool dialog. I'll just move it here a little bit so we can clearly see our model. And this will easily allow you to measure the distance between any two nodes in our model, which is very handy in some situations like we're about to see. So another thing I want to do here before I use the measurement tool is kind of get rid of all of the nodes that I'm not interested in, at least visually, and only focus on the ones that are near the pure column and the extra member. So I'll go ahead and right click within the 3D view window. I'll go to nodes and none, and then that disables every node in the model. Then I'll right click again, nodes, and column. And now we're only seeing the nodes on the actual pure columns, which makes things a lot easier to see and makes the nodes themselves a lot easier to click on when we're about to use the measurement tool. And one more thing we can do is use this increase node size or decrease node size toolbar buttons here to actually modify the node size to make them easier to click. So I'm going to click the first node here, which is the very bottom of the pure column. And that'll mark it directly on the measurement tool. And the second node will be the node that the extra member is connected to. And we can see here, the distance is 4.92 feet, which is not what we originally had. We originally had 1 foot spacing between each of the nodes. So this ended up being exactly 5 feet, which was nice and rounded. So what we'll do here is modify the number of column nodes to get it so that we have a 1 foot spacing again between the nodes. So I'll go ahead and change the number of column nodes to 31. And now we can take this measurement one more time. And you can see we have exactly 5 feet now. So just to reiterate, when you're modifying lengths and heights on your model, it's always a good idea to double check things that are connected to those nodes and make sure they didn't get accidentally moved. So let's go ahead and close out of this measurement tool. And usually whenever I'm done modifying the inputs on a specific page, I like to use that as kind of a checkpoint and save my model, just so in case anything happens, I can go back to it. So save our model, and let's go ahead and navigate to the bridge page. And I want to shift my model so that the 2 substructures that we have right now are substructures 2 and 3, not 1 and 2. So we're basically just moving it to the right by 1 substructure. And the easiest way to do that is through a combination of adding and replacing substructures in a certain order. So using these buttons right here on the bridge page. So let's first add a new substructure 3 based on substructure 2. So our source is going to be pier 2. And we'll keep the positioning for the new substructure by default. We won't mess with the positioning at all, just for the sake of time. Press OK. And now you can see piers 2 and 3 are exact copies of each other. And now we want to replace pier 2 with pier 1. So we'll use this replace button here. And press OK on the message box. And then our source for this one is pier 1, so that's good. Our target is pier 2. Okay. And now we've got pier 2 and pier 3 where we want them, but we need to change pier 1 to represent an end bit. So we'll actually replace this one as well. Okay. But this time we're replacing it with a default bent, since we don't have one built up yet for this model. So we're going to replace it with a default bent, and that'll open up bent-related, end bent-related input options for us. So default bent for the source and pier 1 for the target. And now we'll get a message box here that says that a span cannot be created. And that's because substructures 1 and 2 have a different number of bearings. But we'll fix that in a moment. So we'll press OK. And let's go ahead and save our model. So let's make a few changes to this first end bent to get it connected to the rest of the bridge, and also explore some options we have to transfer data between substructures quickly and efficiently. So let's select substructure number 1 and navigate to the pile grid page. And now you'll see that the pile grid page has actually been renamed due to the model type that we're currently working with. So if we were working with the pier model, it was the pile cat page before. So now we're working with the pile grid page, and we're going to click on this grid spacing table. And this dialog here was pretty explained in detail in the first webinar, so I won't cover this too much, but the only thing we want to change here is this constant XP spacing. This changes from 60 to 100 inches. And we'll press OK. And we'll also change the pile head elevation to 20 feet. Okay, and let's save our model here. And now we'll navigate to the pile page. And what we're actually going to do here is use these same piles as the adjacent pier, pier 2. And now we could copy over all of the properties using the various dialogues under this edit button here. So we could use all these dialogues to copy the widths, geometric material properties, everything like that. But a much faster way to do it is to actually use our database feature that we have. So let's go ahead and select substructure 2. And then we can click on Edit Section Description. And let's click on this Add to Database button. And we'll call it custom pile underscore pier 2. And what this will do is actually create a file in your local folder system to represent the current pile type that you have defined. And this is great because you can use this to, or you can use that file to pull information from for all other models that you're making. So we'll press cancel on this dialog here. And we'll go back to substructure number 1. Edit section description. And this time we'll retrieve the section. And it was a rectangular section. So you can see this new section that we've saved to the database has now shown up here. So we can directly retrieve that, and it'll retrieve all the inputs related to that specific section, just like that, instead of having to go through all these dialogues and double check, make sure you didn't make any mistakes when inputting the same data. So we can press OK on here. And now we're good with the piles. So we'll save. And just want to reiterate, this feature is also available for other parts of the model, like columns and extra members as well, in case you'd like to copy those properties. So let's say we also want the same exact soil properties. So let's go to the soil page. And the way to quickly import soil data is using the import and export feature that we have. So we're actually going to use the import button and import from this file itself. So let's click on import, and then we'll click on bridge 2, or whatever you named your file. And this will allow you to select a substructure from which you want to import soil data. So we'll click on substructure 2 to grab that soil data from pier 2. We'll press OK. And now everything's been ported over. And if we had, this is a pretty simple soil layer, but if we had, complex layering, you can see how much quicker this would be than trying to manually kind of copy all that over. Another way to do it would be to first export the soil data from the second substructure if you had used the export button here. So you don't have to follow along here, just want to kind of showcase this real quick. So you can click on the export button, and it'll export a text file that only has the soil data on it. So then you can import from any other model or your current model just this text file. So again, just another way to do it. But if you're just importing from the same model, if you have multiple substructures, you can directly import from the same model file. So the soil is good now, so let's save it. And finally, let's go to the bent cap page. For the bearings, we're going to again copy over again from our second substructure some of the information. So, but this time we're copying over tabular data. So I'll show you an easy way that I like to use to do that. So let's go ahead and go to our second substructure. And we'll click on bearing locations. And since we only have one bearing row on our end bent, we're going to copy just the data from one of the rows. So I'm going to go here and left click and hold on the first editable cell here and drag all the way down until it covers all my data, and then just Control C to copy that entire column. So we'll cancel out of here since we don't have any changes we want to save. We'll go back to substructure 1. We'll go to bearing locations. And before we can paste in our data, there's a few changes that we have to make on this dialog. So first, we have to select variable bearing spacing, since it is not uniform. And we'll actually use 6 bearings instead of 7. So let's change that to 6. And now we can click, just single left click on the first editable cell in this table so that it is highlighted, and then you can directly paste in your data here. And you can see all the relevant cells in this table have been filled up. And now the last thing we have to do is delete this last entry of 5 feet, which was just carried over from when this default bent model originally had 7 bearings. So we'll just delete that, and we'll press OK. And now we've got our bearings defined. And now we can go back to the bridge page. And we can see now that we have the span now finally generated between those two adjacent substructures, now that we have the same number of bearings. So let's save our model here. And so now at this point, we have our first 3 substructures completely finished. They're in the correct positions. And I would say we're about 95% done with this model. The last thing we have to do is pretty much just mirror piers or bent 1 and pier 2 onto the other side of pier 3, and which is very easy just using the add button here on the bridge page. So we'll go ahead and add, and we'll use pier 2 as our source since we want to add this as our 4th substructure. So we'll press OK. And then one more time, we'll add pier 5 or substructure 5 based on end bent 1. So substructure 1 is our source, press OK. And now we have our full bridge model. So let's go ahead and save this. Now the model is ready to be run using the engine, but before I do that, there is one project setting that I want to change that will hopefully speed things up during our analysis. So let's go up here to the control button on the menu bar, and we'll go to project settings. And then under analysis, we'll click on analysis page. And let's change this analysis cores requested to 2. And what this does is it allows the analytical engine to use multiple cores, CPU cores, on your machine, which most of the time significantly decreases the analysis time of your model. Now, this greatly depends on the model itself, on your machine. There's many variables to this, but usually going from 1 to 2 analysis cores, and it results in a pretty good speed up. So I'll press OK on here. And let's go ahead and finally run the analysis. And I will say that from my testing on this specific model on my machine, the original 1 CPU core analysis time was 20 seconds, and with 2 CPU cores for me was 8 seconds. So more than double speed up, which was very good. So let's finally take a look at some results. Let's go to the 3D results. And Let's enable the bridge view so that we can see some actual bridge results. And now this is very similar to the normal 3D view. You can, rotate, pan, zoom, whatever you need to view your entire model. You can see all the loadings on the different piers. And if we right click on here, again, lots of functionality available on this context menu. We can use the element forces button to open the element forces dialog and click on any of the span elements along the spine model and directly see the data in a tabular form. And then again, another option is the bridge span force plot, which shows you the shear and moment diagrams, and you can also choose to plot them all at the same time for all of the spans. I'll close out of there. All right, and looks like I have a little bit of time, so I will cover the ops model now. And let's go ahead and go back to the edit side of the program. And let's go to the model page. And what we want to do here is convert this model into an ops model. So clicking on this ops model radio button will trigger that conversion process to transform your model into an ops model. And what this will do is run a preliminary analysis that takes your entire bridge model and calculates the equivalent stiffness for the two springs that are placed at the end of the spans adjacent to your selected pier. So let's go ahead and press yes on here to save it. And then this is our pier selection menu here. So we want to select pier 2, which was our original pier from the previous webinar. And we'll press OK. And now, as I mentioned before, this is useful for when you have a large model or lots of load combinations, or you're using dynamics, anything that causes a long analysis runtime. And you're only kind of interested in the behavior of a particular pier. So let's press OK on here. And now if we analyze this model, it should be even quicker than just using 2 CPU cores on the regular bridge model. Yeah, that was about like 1 or 2 seconds. So, and then just as a reference, for this model in my testing, it ran about 4 times as fast as the original bridge model. So I think that's it. So that's it for the demonstration. Again, just to summarize, we took the pier model and transformed it into a bridge model and then into an ops model. And we saw what each step of the transformations looked like and what parts of the interface were specific to bridge models. So, Anand, do you want to take it away?
Thanks, Wilmer. So we got one question from Sangam. Nitesh. So he was asking, can you show an example for custom bearing input? So we need to maybe if they want to do like a gap bearing, or if even you can have hinge, you can have fixed, we have that, and you have a custom. So maybe just give an example for custom.
Sure, yeah. So let's go ahead and go here. We should be able to see the bearings on this ops model. So we can go to, if we wanted a custom bearing condition, on the bridge page here is this edit supports button. And yeah, I don't think I showed this dialog in the demo, but I only showed it in the slides. Mm-hmm. So here is kind of your presets for the bearings that you can use. If you wanted a pin condition, or if you wanted everything kind of fixed, you can use the integral condition to constrain every degree of freedom. And then we even have an option for custom bearings, which is a lot more freedom if you want to kind of have a customized load displacement curve per bearing. So you can have as many curves here as you would need, and there's also options for translational or rotational springs as well.
Nice. So yeah, so here you can supply your own custom bearing, and after you supplied, then you're just adding the bearing definition here. And on the next page, you have to apply it which degree of freedom you want. So you can have translation or rotational spring. So you'd assign that or develop that, and then you assign it in this page. So it comes in your drop down. There's a custom one. So as soon as you make a custom, all of these were included. Currently it has 0, 0, so it will have no resistance in that direction if you use that custom currently, because there's no value in there. Okay, so we have a few more questions here. Let's go one at a time. Would you please explain the cases of continuous girder and deck only? So we have, so there is a continuous member, right? Wilmer, can you show that
Yes.
dialog there?
Yes.
Yep.
So let's see. We have this option here for continuous span atop a substructure. And that's only available, just want to make sure to point this out. It's only available when you have two bearing rows. So you can see here the pier is not, rotate this a little bit, it's not visually connected right now, but if we click this, then it is connected. And now there's an additional option that's available. If you click the Edit Span button, we have this continuity element button available now here. If you didn't have this checked, this would be grayed out because there is no element there to customize. So now here is where you can directly input your gross properties for that specific element there. So you would have these, you would click on the custom radio button here, and then have these properties match whatever properties you input for your slab.
Yep,
So
and this is one of the advantages of using that bridge model. You can have the continuity element in there. For some cases, I think you also help elevate some of the moment reduction. Maybe we can go deeper in the next webinar on those points, which are the advantages of the bridge. So thanks, Wilma, for showing that. Does the next one is, does the ops model get saved as a different file name?
yes.
Yes, we just saw the file name on the top there. So whatever the file name was, the first one gets converted underscore ops and the peer number you want to make it, and it saves it as a different file name. Yeah, we don't mess with your original bridge model. So yeah, so that answers that question. How would you how about skew angles of pier and wind load direction? So we definitely could skew, you can skew your piers, and then if you go in the program, you can go in and see on the bridge page. Yeah, so you can have rotation, and you can provide different rotation of your piers. Yeah. So if you go on the for doing the wind load generation by the program, so if you want to do wind load generation or you apply your own wind load, all of them are applied on where the bearing direction is. So in this case, you can change the bearing as well to go with the pier or with your superstructure. So you can have angles of that as well. You can see left bearing row and right bearing row that has an angle with it. So currently it is just 0, 0. But if you say 30° on the same page, Wilmer, on the main page, if you do 30° there, so it will move with your pier. But yeah, so you can assign, and the wind load that you're applying, it will be on the bearing. So whatever the coordinate you have for the bearings, that would be you're applying the wind in the program. So we have a few more questions. Let's go faster on this. On the full bridge model, the end bend only indicates one force load at the end compared to the interior on each bearing. Can you clarify? It seems that when Wilmer was creating the bridge model, he just kept some load in the corner for the bend. I don't know if it was not on purpose or anything, but yeah, it's just a demonstration he wanted to go over. So I don't think so there was a reason for that. But yeah, if we had a little bit more time, we would have put all the loads on all the bearings on the bend. There was no specific reason that we did that on this. But thanks for pointing that out. Yes, we do have, there could be another step where you apply it on all the bearings on the bend as well. So in custom bearing input, do we input displacement in both positive or negative for the bearing to move in either direction, or the model is intelligent enough to apply the spring stiffness in either direction? That's a good question. I think we do have it understands it. Um, that's a good question. You can have in two direction, I think. Clint, could you confirm that? I think you can have positive or negative, but if you do not have positive or negative, then it will apply in both direction then. I think that's how the program uh, does it. But I can check, like do some example model for you and send it. So with the limited time we have, I do not know for sure, but I think my instinct is, hey, this is, you apply when it starts from 0, then the program knows, hey, this is the bearing stiffness in both direction. But if you have in positive and negative, it will use that. But I'll confirm that though. How can you add curves super elevation to bridge model where pier are not in line? How could you add curves super elevation to bridge models where piers are not in line? Oh yeah, so if it is not in line, as you can say, like you can have different coordinates for each of your piers. So Wilmer, if you move your pier in the middle pier in X and Y direction out, like out, not in the line, right? If you move it out, and then by default, the program will attach the both the pier together with a straight line superstructure. But if you have a curve, we have an option where on the bridge page, you can have user defined coordinates for your span, and you can supply like up to 10 points on your superstructure, and the program will curve your superstructure on that. So if you can show that here. So this is by default the coordinates for all your nodes on that superstructure, and then you can change that to make it a curve. So yeah, you can do that in the program. Did you mention that this program can accommodate curve alignments? Yes, yeah, this is how you do the curve in the program. If so, can the bearing be oriented to align with the direction of expansions? Yeah, so we have in the program, you have rotation for your pier, right? So that's you start from there. So rotation of pier, and then you can bearing could rotate as well. And the superstructure, you can apply curve on it or user defined as well. So I think you can do what you're trying to do there. If you are not able to do it, let us know. If you have a specific question or specific case that you're doing, we can help you do that. But definitely you can have the bearing alignment in any degree that you want in there. Sangam says, thank you. That would be wonderful. Okay, so that will be helpful. So Sangam, like I'll reach out to you uh, to follow up on your question if you it wasn't clear. But yeah, so uh, to the 2 degrees of, yeah, I remember you said in X and Y, X plus positive and the negative direction. So I'll definitely look into that and let you know. We have another question. Are there plans to create shear plots in the 3D results, pile cap forces similar to plus minus moment? So we do have shear in the 3D. Wilmer, can you show it? I thought we
Sure.
do have it there. So right click on the 3D and then to the plot, the span, bridge span plots. Yeah. So if you go to the span forces, select a shear in there, in the forces. So I think you meant to ask us about this. So the shear is in the part of that. Let me know if that answers your questions, but moment and shear, both of them are there. For pile caps, not superstructures. I see. So if you go to the pile cap, Wilmer, right click and say pile cap forces. If you go,
I think I need to get out of bridge view here for that.
okay, yes,
And
thanks.
then pile cap force. Yeah.
Yep. So if you select some set of nodes, I know we have 1 minute, so I think we can get this. Just select any row. We want to just see what the forces are. I think that's what he's trying to. If we have max and min forces, I see what you're saying. So if we do the shear in there, okay, I think we do show shear, but we just say get one number on that section. We don't show it along it. If there is a need for it, definitely, yeah, we can look into adding that. Thanks for that input. We can definitely look into adding that, but we do show shear here. There, max shear. Yeah, so we do show max shear here, but we can look into if you want a profile of the shear, of how we got to that shear, if you need each of the shear per unit length along that section. Yeah, definitely we can look into that. Yes, Dave. Davey, definitely we'll look into that. Thanks for the input. Just to confirm, we can't use a curve equation, vertical or horizontal, to define the curve, right? We will need to coordinate, we'll input coordinates at various points of curve. Therefore, the curve will be made of multiple coordinate segment. Yes, yeah. So just to confirm, we can't use curve equation, vertical or horizontal, to define a curve, right? That's a good input. Like we can look into that to facilitate a way. If you have a reasonable, like a curve that is used usually, an equation that you guys are using usually, we can definitely put something in here to get that curve dimension depending on your x and y coordinate, and a few more input parameters we can see, and it could be a nice addition if there is need for it, definitely. So Stanley, please get back to me on that. If there is a specific equation you guys usually use, we can look into that. But at this moment, we don't have a way to convert that. You have to manually convert all those data to the coordinate and then put it in the program. So I think we answered all the questions here. We did really good. I think we did go through all of them. So we are out over 2 minutes here. So I just want to quickly go over like a few things. Thanks for your suggestion today. Please follow up with me if we have not completely answered your question. So definitely get back to us. And I'm going to get back to Sangam for one question. So the next webinar we're going to do is bridge models in FB-MultiPier, January 21st, 2026. And that's the only one we have scheduled for now, but we're going to add more to the webinar. Please get back to us if you have a topic that you need, if you are interested in. We'll definitely cover it, like vessel collision, fender modeling, or any specific modeling like you want us to do. Let us know. We can work on that and then add it to the webinar series. We will provide CE credit for anyone attending today. We can provide you 1 hour of credit, and we'll send that to you pretty soon as well. So I think that concludes the webinar. Thanks, Wilmer. That was a pretty informative webinar. And please reach back to us if you have any further questions. So that concludes the webinar. Thank you.
Thanks, everyone.